Thank you for joining. My name is Tanner Yes. I am the co-executive director of Groundwork Ohio River Valley. You have joined on a fitting evening where we've had a bunch of rain all day. We're honored that you're choosing to spend this time with us, and we're really excited to share out some new work with both local and regional perspectives involved. So let's jump right into it. I want to quickly introduce all the presenters today. The rundown of the show today is that we're going to talk a little bit about the partnership, but the main part of the presentation is going to be from NASA Develop, our partners there, and they're going to share with you new landslide and flooding data and models that they've run with something called the INVEST model. After that, we're going to turn to the City of Cincinnati's Office of Environment and Sustainability for some local perspectives, and then we're going to include Green Umbrella and Groundwork Ohio River Valley in a panel. So to introduce everyone today, we'll start with NASA Develop, Celeste Gambino. Celeste graduated from Boston College with an MS in geology, where her research used geochemical analysis to assess Arctic permafrost sensitivity. In 2019, she is now the Senior Communications Fellow at NASA Develop. Paxton LaJoie graduated from the University of Wisconsin-Madison, earning her MS in environmental conservation, studying coastal ecosystems in Southeast Asia. Paxton joined the NASA Develop program in the fall of 2020, completing 3 terms as a participant and now working as a full-time fellow. Savannah Sullivan. Savannah is currently the climate policy lead at Green Umbrella, where she works with local governments in a 10-county region to kickstart and accelerate climate action. Prior to Green Umbrella, she was a climate and community resilience analyst for the City of Cincinnati, where she led climate equity and community engagement efforts. Prior to the city, Savannah worked everywhere, seriously. Some stops include Indiana University's Environmental Resilience Institute, Rural Action, and Green Chemistry Institute, and the US EPA. She received her MPA and MS from IU's O'Neill School for Public and Environmental Affairs and BA from Oberlin College. Michael Forrester is the director of Cincinnati's Office of Environment and Sustainability, OES. OES is responsible for the Curbside Cincinnati Recycling Program, brownfield remediation, and the implementation of the Green Cincinnati Plan. Michael has a master's degree from Indiana University and an undergraduate from Miami University. Sarah Morgan with Groundwork Ohio River Valley. Sarah is Groundwork's Do-It-All GIS manager. Originally from the DC area, she spent the last decade working along the Ohio River in both Louisville and Cincinnati. While completing her master's in social work, Sarah managed a regional needs assessment centered around community health and access to resources in Louisville. Sarah moved to Cincinnati in 2019 to pursue her master's of community planning at UC, where she studied the role of 20th century development has had on current climate conditions. So we're really excited to have everyone here. A little bit more housekeeping before we get into it. If you have questions, please put them in the questions and answer field and not the chat. We want to aggregate all the questions in the same place. So before we jump in, just a little bit about Groundwork Ohio River Valley and the NASA partnership. Groundwork, we like to say, is where justice and the environment meet. We are one of the only environmental nonprofits in the area with leadership of color at all levels of staff and board. We connect humans to nature in a way that benefits both. So how have we been working with NASA? Well, we've had more than 100 youth employees this year, and we've developed one of the nation's largest youth green workforce programs, and that is in partnership with Cincinnati Parks, Great Parks, and MSD. Many of them have worked with NASA and interned with NASA even, and have worked on urban heat island effects. We also have the NASA Develop partnership, which you will hear about today. The first iteration focused on urban heat, but today we're going to talk about landslides and flooding. And again, if you're in the area, if you watched the mayoral debate last night, you know what hot topics these are and what important topics these are for our region. All of this data is wonderful, and I do have to thank OKI and the Cincinnati Park Board for working with us and helping with us on data. But for us, our mission is really to put the data into action. We do this with something called Climate Safe Neighborhoods. With the partners here on this call today, we've developed the region's first ever neighborhood scale climate plan in Lower Price Hill, which you can see on the screen on your right. And we're working in all 52 neighborhoods and around the region to look at a ground level frontline view of climate change playing out in our city. Climate Safe Neighborhoods allows us to use data to set the course and prioritize our work. So whether it's our youth employees or our education program, we're using Climate Safe Neighborhoods as a platform and as a through line to inform everything that we do. Climate Safe Neighborhoods is a national effort run by Groundwork USA that you should check out. I encourage you to. If you're a map nerd like myself, you'll find a lot of useful information here. So without further ado, let's jump right into it. I'm going to turn to Paxton and Celeste to start the presentation.
So, as Tanner just mentioned, Groundwork USA and Groundwork Ohio River Valley have been working with NASA's DEVELOP program for a little while now. And DEVELOP is part of NASA's Applied Sciences program, and through this, we address environmental and public policy issues through interdisciplinary research projects that utilize NASA Earth observations, addressing community concerns throughout the globe. And through this, we try to bridge the gap between NASA Earth science and society. This is conducted across 10-week term projects 3 times throughout the year. And for this project, our team partnered again with Groundwork USA and Ohio River Valley to assess flooding and landslide susceptibility across the Ohio-Kentucky border. Next slide, please. Thank you, Jen. So, the neighboring cities of Cincinnati, Ohio, and Covington, Kentucky are both densely populated urban environments, and they're very close, of course, to the Ohio River. And the surrounding geologic conditions make these local communities vulnerable to potential flooding and landslides. To meet the goals of Ohio River Valley and Groundwork USA, we focus on the city of Cincinnati and the northern portion of Covington within the I-275 interloop. And we also included a little bit beyond that in northern Kenton County and northern Campbell County surrounding Covington. And the data we used for this project spanned from 2004 to 2021 so that we could focus on recently occurring storm events and assess the region's flood and landslide susceptibility. Next slide, please. So our goals for this project were threefold, and we incorporated several objectives to provide Groundwork USA and Groundwork Ohio River Valley with their goals. The first objective was to utilize the INVEST urban flood risk mitigation model to identify areas with the greatest risk of flood and associated damage. We did this by using the model to calculate potential stormwater runoff, runoff retention, and potential service values of the affected infrastructure within the study area. The INVEST model outputs allowed for our partners at Groundwork USA and Ohio River Valley to better identify areas of highest flood risk within both cities. Our next goal was to map regional landslide susceptibility and exposure using NASA Earth observations. The gridded landslide susceptibility maps will hopefully better enable both Groundwork USA and Ohio River Valley to identify areas of concern at a finer spatial resolution than they have been previously. And these maps will also ideally allow them to assess landslide vulnerability relative to targeted populations and certain infrastructure in the area. We also wanted to create a methodology for producing consistent flood and landslide vulnerability maps to aid Groundwork USA and Groundwork Ohio River Valley in reproducing this analysis for other cities and within these same 2 cities in the future. Next slide, please. So, as mentioned, we wanted to use the INVEST urban flood risk mitigation model. And INVEST stands for the Integrated Evaluation of Ecosystem Services and Trade-offs. And this model is produced by the Natural Capital Project out of Stanford. And we used this to illustrate Cincinnati and Covington's runoff retention capacity. And we also wanted to just note that these results include stormwater values because this model is not capable of assessing riverine data, so we weren't able to identify flooding associated with the Ohio River. So this model requires several inputs to generate runoff retention, runoff values, and flood risk service. This included a land cover raster map, a watershed vector, depth of rainfall value in millimeters, a raster map of soil hydrological groups, a biophysical table containing curve numbers associated to the different soil types in the area, and 2 optional inputs to produce the flood risk service output, which was a shapefile of built infrastructure and a damage loss table associating the infrastructure with different dollar amounts. To create this biophysical table and map the land cover within the study area, we used the 2010 USGS National Land Cover Database, And we also used the USDA Gridded Soil Survey geographic soil type and drainage class data sets from within this study area to determine those soil curve numbers. The input depth of rainfall in millimeters was derived by our team from referencing different storm events known to have caused flooding within both Cincinnati and Covington. They were chosen to approximate different depths of rainfall based on those storm events and determine a range of rainfall causing flooding and landslide events in the region. So we chose to run the model at 60, 90, 120, and 150 millimeters based on different averages of storm events and also what the 100-year storm event looks like within the area. The INVEST model produced primarily raster outputs regarding runoff retention, flood volume, and damage to built infrastructure. And these outputs allowed us to quantify and visualize the impact of these rainfall amounts and different storm events and the overall flooding capacity of the area. Next slide, please. So as I mentioned, one of the inputs for the INVEST model was a land use land cover raster map. And so this is the land cover data from the National Land Cover Database from 2010 that we utilized. The urbanized areas shown in varying shades of purple, from light being the least developed to dark being the most developed, are showing highly urbanized areas further in downtown Cincinnati and other major neighborhoods in the area. It also includes a lot of different impervious surface, such as buildings, roads, commercial, and industrial complexes. And the land use data was used in the INVEST model to determine where flooding susceptibility is likely to occur based on a given storm size. Since impervious surfaces have almost zero runoff retention capacity, the purple areas are most likely to experience flood resulting impacts. Assessing the land use land cover in our study area helped us validate our results in the runoff retention and runoff value consistencies based on these land use trends. Next slide, please. So the first output of the INVEST urban flood risk mitigation model was the runoff retention map. And here we've included two runoff retention maps that were created to distinguish the difference of an average storm size event for this region, a 2.3-inch storm event per day, and a much larger storm event that is both rare in frequency and size. And so that's the 6 inches of daily rainfall storm event. The map to the left, which is the 2.3 inches per day storm rainfall event, indicates much closer to 100% retention capacity. And that's shown in the darker areas on the map. So for instance, in the northwest corner of the study area, we know that that is a forest and that retained a significant portion of the rainfall. Whereas in the map to the right, you'll notice that even those areas that are less urbanized and initially retained much more water had a lower capacity to retain the rainfall in the 6-inch daily storm event because the whole area was just overwhelmed with rain. Next slide, please. Because the INVEST urban flood risk mitigation model assesses flood risk based on land cover type and associated soil curve numbers, we were able to determine the runoff retention per land cover class for each storm event. And so these land cover classes were determined based on that national land cover data set that we used. And we noticed that forests provided the most runoff retention, retaining nearly the entire rainfall volume of both the 2.3 and 6-inch events respectively. Meanwhile, the urban areas were increasingly unable to retain the stormwater as impervious surface percentage increased, and areas like wetlands, grasslands, and agricultural lands were also beneficial land cover types, contributing to stormwater retention in the study area. Next slide, please. The second raster output from the INVEST urban flood risk mitigation model was the runoff map. And this is essentially the inverse data of the runoff retention. And it shows that as the storm size increases, so does the percent runoff value per area. So from the small rainfall event on the left, again, 2.3 inches of rain per day, to the larger event on the right of 6 inches of rainfall per day, this change is most notably shown in the highly developed communities, where we initially saw the very dark purple land cover and are now seeing the dark purple runoff. And this is because there's a higher increase in percentage of runoff occurrence. And the areas with very little runoff are the same as those with the high runoff retention, so namely the forests. But Areas like downtown Cincinnati cannot support additional water from these high rainfall storm events and definitely contribute to flooding within the area. Next slide, please. And again, consistently with the runoff retention per land cover class, we also determined the runoff per land cover class, which indicated little ability of the increasingly developed areas to retain stormwater. Runoff was very low in the forested areas, with similar low values shown in agricultural lands, grasslands, and wetlands again. And once again, we saw that in the increasingly urbanized areas, there was very little capacity for any rainfall to be retained. And we did this because identifying specific contributions that these different land cover types make to stormwater retention will hopefully help our partners at Groundwork USA and Groundwork ORV to identify these areas of concern and help make recommendations to mitigate that flood risk. Next slide, please.
All right, I'm going to be talking about the second part of our project, which was looking at landslide susceptibility and exposure in the area. And apologies, Tanner, for this being an animation. If you want to click a couple times, we can just show the whole thing. One more time. Perfect, sorry about that. So I'm going to talk a little bit about our landslide mapping. So to create our landslide susceptibility map, we first had to identify what factors or landslide factors were relevant to this particular study area, which you can see on the left. We selected elevation, slope, clay percentage, roughness, local lithology, change in vegetation, and distance to roads as the dominant factors contributing to landslides in the area. These decisions were made on pre-existing literature and then consultation with a local expert, Dr. Matt Crawford of the Kentucky Geological Survey. So these data sets for each variable were obtained and then run through a weight of evidence model on ArcGIS Pro, which standardized and resampled the data. So the rasters were then all overlaid on top of each other using a fuzzy overlay model and then combined ultimately into one final landslide susceptibility map, which we then used a historic landslide inventory obtained from the USGS to validate. Next slide, please. So here you can see our overall final susceptibility map that was reclassified by percentile to showcase different landslide susceptibilities. A previous developed project had similar work, so we elected to do something that they did as well, which was classified as 50th, 75th, 90th, and then 95th percentiles for the 5 categories of susceptibility assessments, which reflect very low, low, moderate, high, and very high areas of susceptibility, respectively. This ensures that we're accurately communicating the region's susceptibility, as very high susceptibility is reserved really only for areas that are in that top 5% of quantified susceptibility. And along the map, it reveals that certain major roads, including US Route 50 and then Kentucky Route 8, are zones in very high susceptibility, following that curve of the Ohio River, which is of course reminiscent of the many landslide that peppered Columbia Parkway in 2019. Next slide, please. So only a subtle change on the map here, but to validate this susceptibility map, our team considered a frequency ratio analysis, which used a landslide inventory provided by the USGS and Kentucky Geological Surveys, which provided insight into whether or not areas that we deemed high susceptibility in the map were actually associated with areas of more frequent landslide events. So the landslide inventory, which was 125 total landslides in the past few years, used in the frequency ratio analysis is shown here in those purple dots overlain on the susceptibility map. So each purple circle represents a point location of an individual landslide event. And there's a spatial correlation here between areas identified as very high susceptibility and the actual physical locations of previous landslides. And this is especially pronounced in the high susceptibility regions alongside certain roads and riverbanks, such as in the southeastern quadrant. We quantified this relationship as well and can discuss it further if there are kind of questions on that later on. Next slide. So after doing that validation, the team used the susceptibility map to create a series of exposure maps. And just to differentiate between those two, susceptibility really refers only to looking at geologic factors, but exposure is the combination of that susceptibility and socioeconomic or population data, so adding people into the equation. For the Cincinnati and Covington region, the team focused on 3 specific socioeconomic factors: poverty, the population of elderly residents over 85 years old, and then the population of African American residents. So to conduct the analysis, the average landslide susceptibility of each census block group within the study area was calculated. And then the 3 socioeconomic factors, again, just at census block group resolution, were joined to that susceptibility map. And the result is 3 separate maps that we'll see in a second that highlights the intersection of landslide susceptibility and then that respective socioeconomic variable. So Tanner, if you want to flip to the next slide. The first one looks at census block group level, the individuals in poverty in 2019 at a bivariate colorscape. And this again is joined to the previous landslide susceptibility map to highlight the vulnerable populations that are exposed to landslide. So if you look on the x-axis in pink, that is showing the population in poverty. Areas in blue are the landslide susceptibility, and that darker purple region is the intersection of high susceptibility and high percentages of those in poverty. Next slide, please. So this is looking at same thing, except now for elderly residents over 85 years old. Male and female data was combined to produce a single elderly data set for the study area. Again, with the bivariate color scheme, this time with elderly residents shown in orange. Next slide, please. And the final factor that we looked at was for African American population data, again at census block group resolution. And this was chosen specifically because this was the largest minority population in the study area, and our partners at Groundwork wanted to specifically look at the vulnerable parts of this group. Again, visualized in the color scheme with red showing high percentages of the African American population density. Next slide, please. So this landslide exposure map is produced by combining all 3 of those previous vulnerable population data sets to produce one final uniform map that focused on the kind of overall general exposure for the area. So landslide susceptibility was used in relation to vulnerability to create this kind of final exposure map, showing the many intersections between vulnerable populations, again, which are just these 3 groups. We could have added more in, or more could be added in future work, who might be less resilient to landslide events. A few neighborhoods in particular that had high combined vulnerability and high landslide susceptibility were North and South Fairmont, along with the area around Avondale. All right, next slide, please. So in conclusion, urban areas like downtown Cincinnati experienced much more runoff, and less water was retained than in highly forested areas in the Northwest. In particular, the downtown Cincinnati, Queensgate, and Over the Rhine neighborhoods retained the least amount of precipitation. And as validated by our frequency ratio analysis, the landslide susceptibility map accurately reflected the locations of previous landslide events. Frequency ratio analyses on the individual variables that we looked at also showed that slope was the most predictive variable in determining landslide susceptibility, and specifically steep slopes near major roadways like US Route 50 or 72 in Ohio, and then Kentucky Route 8 had very high landslide susceptibility. Beyond that, regions in southern Kentucky appeared to be especially susceptible to landslides. The exposure map showed that there are many intersections between different vulnerable populations and heightened landslide occurrence. And 2 of those such neighborhoods with that high combined vulnerability and susceptibility, again, were North and South Fairmont. Next slide, please. And like in all work, it's good to point out what the uncertainties and limitations were. Again, this was a 10-week project, so it's definitely a good starting point. But in terms of specifically for the invest portion of the project, most of the uncertainties and limitations arose within the inputs to the model. So the invest model relies heavily on clearly defined and complete watershed limits, and watersheds within this study area in particular had certain portions that were outside of the area of interest that we were looking at. So the impact on this discrepancy when we checked appeared negligible, And we partially accounted for the inclusion of this sewer shed level analysis specifically within Hamilton County. And like Paxton said earlier, this model only assessed precipitation, rainfall-based flooding, not riverine flooding. And for the landslide portion of the project, the inventory that we used was compiled by the USGS and the Kentucky Geological Survey in order to validate that susceptibility map, but it's non-exhaustive. And this kind of inventory that might be missing certain points might undercount landslides in other regions and would potentially introduce uncertainty into our validation process. So a similar effect would be observed if the points that we were looking at were inaccurate, in the wrong location. So if a landslide point was mistakenly reported in a different susceptibility category, our validation process would record a different level of confidence in our map. But that's it for us. Again, thank you so much for having Paxton and I. It's been a pleasure to work with Groundwork these past 2 terms. And at the end, we'd be happy to take any questions.
Thank you, Celeste and Paxton. It was a true privilege and joy, of course, to work with NASA Develop. The INVEST model, if I have this correct, this was only the 2nd time it was used nationwide, and we got to use it in our area, our region here. So we still retain that model. We will be able to use it and update it as time goes on. And again, we're going to save questions for the end, and I'm going to jump right in and pass the baton to Michael Forrester with the City of Cincinnati.
So first, Tanner, let me say thanks for having me here today, and Celeste and Paxton, this is great work. Hello, everyone. My name is Michael Forrester. I'm the Director of the Office of Environment and Sustainability. My office's mission is to make the City of Cincinnati a more sustainable, resilient, and equitable city through the enactment of the Green Cincinnati Plan, which lays out 80 recommendations to reduce the City of Cincinnati's carbon emissions 80% by 2050. Since 2018, we have accomplished a lot. We have completed or are on track to accomplish more than 75% of these recommendations laid out into this plan. And while extreme weather is increasing, the city is adapting its process to make it a more resilient Cincinnati. I want to provide resources to the attendees on this meeting if they are impacted, and you'll see contact information at the end of this presentation. We know that the threats from climate change and extreme weather manifest themselves in heat, water, and landslides. And I'm going to talk a little bit today about the city's actions to mitigate climate change and some of the city departments working to address these issues and these impacts of some of the larger storms and some of the direct actions that we're taking to make Cincinnati a more resilient city. Next slide. So first, when we talk about landslides, we must talk about our Department of Transportation and Engineering, which manages our roads and bridges and the retaining walls that are impacted and serve as landslide mitigation for the city of Cincinnati. Generally, DOTE is responsible if public infrastructure is impacted or if city property is impacted. However, should a slide occur on a private property, generally the property owner is liable for any repairs. DOT owns and maintains over 1,551 walls totaling 51 miles. And I want to highlight in these figures that what you're seeing is landslides and landslides preventions. They do have costs. And I've included a couple of examples here in this slideshow showing the before and the impact as well as the overall costs. And I show this not to scare you, but instead to highlight that hillside stabilization and climate adaptation has real costs. Next slide. Here we see the largest hillside stabilization project that the city has recently undertook over Columbia Parkway. Coincidentally, this project was also officially completed today. However, you still may notice delays as the roads are resurfaced. This project spanned almost a mile and cost almost $18 million. It required soil pinning, where steel nails are driven into the hillside, which attaches a wire mesh to the hillside in order to stabilize it, as well as building a secondary wall in some sections to further secure the hill. Next slide. When we're talking about hillslides, we're often talking about the water and the weather that causes them. And I want to briefly touch on 2 city departments that deal with rainfall and the differences between the two. Often as a resident, when you see water, it's just water, whether it's in your basement or whether it's outside. But in city operations, it's slightly different. we have two separate departments that deal with stormwater. First is our stormwater utility, which collects and manages the surface water that flows through our creeks and channels and our storm sewers. This is the infrastructure that goes directly into our natural bodies of water and is not treated. Second is MSD, which manages the combined and sanitary sewers, the treatment of wastewater, and the remediation of verified sewer backups in homes and buildings. Next slide. So in order to build a more resilient city, the coordination is required between our departments and others. We realized this when we first undertook an extreme weather analysis. So in 2016, the City of Cincinnati centralized the review and the permitting process led by our Buildings and Inspections Department. This process allowed for all the departments involved in the permitting process to discuss with the developer and the builders potential issues and ensure that we build a better city. Here is where departments work together to address issues like hillside stabilization and impacts to stormwater and sewage capacity. Here we hope to get out in front of problems as we continue to grow our city. Next slide. But even as these departments work hard, we must acknowledge that the environment that Cincinnati was built for is changing. A rainstorm and a heat wave is different. Our climate will change, and all the data points that the city of Cincinnati will more closely resemble Little Rock, Arkansas in the summer and Washington, D.C. in the winter. We've already warmed 2 degrees since 1950, and the rainfall has increased 13%. On average, what's most striking is what's happening to our extreme weather. The warm air is holding more water, and we're giving the storms a bigger bucket to dump on us. Our extreme rain events are dropping 35% more water than they used to, and they're occurring more frequently as well. We're seeing these impacts of climate change here in Cincinnati. Next slide. What we see here is the 100-year storms in Hamilton County. So these are storms that have a 1% chance of hitting every year. These are the largest storms that have occurred over the past 10 years, and we've seen 9 events. What I want to highlight here is the lightest rain is a green, and the more intense are red to purple. What you're going to notice in these pictures here is small, powerful microbursts of rain that occur fairly random throughout the county. When these microbursts combine with topography, impermeable surfaces, drainage basins, this is where localized flash flooding, this is where hillslides are likely to occur. Our current system just becomes overwhelmed, and we cannot move the water away fast enough. I want to highlight the storms of 2016 right in the middle on the top row there. What you're going to notice is that dark purple spot exactly where the Columbia Parkway project took place. You can see that these extreme storms impact the infrastructure in the hills that we live on today. Next slide. Here's another example of the extreme weather impacting the city of Cincinnati. This is an extreme storm that took place on June 30th. In the microburst areas, the red and the orange, this is where we see a significant increase in flooding and combined sewer overflows. You can see they're almost directly correlated. Next slide. Keep going. So what do we need to do? So first, the city of Cincinnati is working to reduce our own carbon footprint. The 1,000-acre solar array that we're currently being built 40 miles east of the city of Cincinnati is an excellent example of us doing big projects to have real emissions reductions and to save the taxpayer dollars. Second, we must gather data around our vulnerabilities of our city in a changing climate. This report that was presented today from NASA and Groundwork is an excellent example of the information that the city needs to build a more resilient city. Third, we must engage the public, you, to understand what once was is changing. We must talk to people in events like these. We must provide education. We must provide outreach so you can understand the potential impacts to your homes and your businesses. Everyone on the coast knows what steps to protect themselves when a hurricane. But what does storm preparation look like here in the city of Cincinnati? And how do we share that message with our residents? 4, we must do things here differently. The way that we built infrastructure in the city is shifting. We can't always build a bigger pipe or a larger wall. Sometimes it takes a new way of looking at a problem and finding new solutions. Again, the Lick Run Greenway is an excellent example of how this can be done. And finally, we must look towards the future and develop policies and regulations that react to a changing environment. What we have now are designed for previous issues, and we must work with the city administration, the city council, and you, the residents, to analyze best practices across the country and come up with our own ideas to determine how to make the city of Cincinnati a more sustainable, equitable, and resilient place. Thank you. Go ahead and turn to the next slide.
Thanks,
I have
Michael.
resources on there if anybody has concerns about flooding from either a stormwater backup or from overland flooding as well.
Thank you, Michael. Those will be sent out with the recording and other resources, so you can have all of that information in your email box as far as those contacts. So thank you, everyone. That concludes the main portion of the presentation. We're going to open the panel now, and I want to do so by introducing Savannah Sullivan, again with Green Umbrella. Savannah, I want to start with a question. What are some of the best flooding and landslide practices from cities, counties, and other forms of government that you're aware of?
Hi, everyone. Thanks, Tanner. Great question. So as Tanner said, my name is Savannah. I'm a climate policy lead at Green Umbrella, the Regional Sustainability Alliance in Greater Cincinnati. We lead collaboration, incubate ideas, and catalyze solutions in the region and a 10-county footprint: Butler, Claremont, Hamilton, and Warren in Ohio, Boone, Campbell, Grant, and Ken in Kentucky, and Dearborn and Franklin, Indiana. Just wanted to throw that out there because I know we have folks on the line from all over. So we just heard some really great steps from Michael that the city of Cincinnati is taking. I just want to highlight that, it can be intimidating for both residents and local governments to see these statistics and maps, especially with the background knowledge that the bulk of the responsibility for cleanup and reconstruction after floods and landslides remains at the local level, and often on the individual property owner too. Landslides can be particularly tricky as there's typically no insurance or very limited landslide insurance available for homeowners. This sometimes means they end up seeking compensation from local governments or neighboring landowners. All that to say, for these and other reasons, pre-disaster landslide and flood hazard mitigation is really important for local planners and community leaders. And I just want to highlight some big categories of some best practices and tools, resources, and some local opportunities that anyone on the line can get engaged with. So first, for all jurisdictions, for both flooding and landslides, a really important step is assessing your impact. So thanks, NASA and Groundwork, and your preparedness across your policies, programs, and existing and planned infrastructure, much like Michael just outlined for City of Cincinnati. Resilient communities, they have diverse and redundant and connected and equitable systems, which basically means you need to have a lot of different tools, which means policies, programs, projects in your toolbox. The folks in charge of the tools need to be in communication, and the accessibility and fairness of these tools are critical. In this stage, I want to emphasize community engagement and equity must be centered, and we'll hear a bit more about the climate safe collaboration from Sarah, I know. So one regional modeling tool I want to highlight was recently released from Green Umbrella's Green Space Impact Team with tremendous support from the Ohio, Kentucky, Indiana Regional Council of Governments. The tool is called the Environmental Mitigation and Suitability Model. It's a region specific and enables communities to determine which areas of importance based on their own unique environmental qualities can help decision makers identify where's most suitable for future mitigation investments. So plugging in the type of information we saw today with a few other inputs to help you identify, if you have a specific analysis or project and you're trying to weigh the importance of different factors and see, will I experience more flooding in this area maybe compared to some other areas. You can see a map that presents priority areas for your project of interest and focusing on conservation and resilience. Another tool I can recommend as a best practice is a readiness assessment. And we have a great example in our neighboring state of Indiana, the Hoosier Resilience Index from the Environmental Resilience Institute. And while it's technically Indiana specific, it's very applicable to Ohio and Kentucky communities as well. So what this assessment provides is a method for county governments and incorporated cities and towns to evaluate their community's actual preparedness to risks and helps them identify next step actions. There are almost 80 questions local governments can walk through, both city, county, and other jurisdictions in order to see how resilient they are to specific impacts. So I'll give an example in the planning and land use section. As we know, we can expect more frequent floodplain inundations and surface flooding. And some crucial steps you can take on this front, and these are some best practices, are completing US EPA's flood resilience checklist, participating in the National Flood Insurance Program community rating system, integrating stormwater retention into zoning codes, comprehensive plans and ordinances, and setting previous cover minimums or impervious cover maximums or offering incentives to achieve those same goals. So for each of those recommended actions, governments can select how far along they are in taking important steps to improve resilience. There are a number of actions beyond that from FEMA that I definitely recommend checking out on their website. And it's for a wide range of administrators, emergency managers, and building officials. Secondly, I want to specifically call out comprehensive plans and implementation provisions like zoning codes, building codes, etc. On this front, I really recommend a tool for local governments, the Sustainable Development Code. It provides good, better, and best recommendations for removing code barriers, creating incentives, and filling regulatory gaps across a wide range of climate impacts. For example, there's a whole chapter dedicated to floodplain and river corridor land use, chock full of model ordinances. And we can take a really important step with these NASA developed data to inform a lot of the ordinances we could make here. And on landslides in particular, one state that is doing a really good job is Oregon in addressing landslide mitigation through zoning codes. I recommend checking out the land use guide for Oregon communities. It provides a really long list of resources, including a list of strong features of zoning codes that can protect people, property, and environment from landslide hazards. Third, and for all jurisdictions, consider developing some sort of mitigation action plan or incorporating these climate principles into other existing plans. For example, jurisdiction level sustainability plans, such as the Green Cincinnati Plan, multi-hazard mitigation plans at the county level, or township or village level strategic plans. Get it on paper and ensure accountability for the successful implementation, as Michael was highlighting with the various departments in Cincinnati. And finally, my last point is collaborate. These climate impacts, they don't know jurisdiction boundaries. So regional approaches and collaboration are key. As mentioned earlier, Green Umbrella, we work regionally. One thing we're doing is working to launch a regional climate collaborative. And what this is, it's an approach and it's a network for public agencies to better understand regional climate impacts on communities and how they can advance solutions. In addition to mitigating the drivers such as greenhouse gas emissions. There are already more than 30 collaboratives in the country, and we're joining the list. They've massively accelerated local government implementation, and the Greater Cincinnati Collaborative, it'll facilitate peer sharing, highlight best practices among local governments, develop opportunities for regional collaboration and program implementation. And a key output will be a regional action plan, which can provide a menu of strategies. So lots of different folks can participate. It's not just governments. We'll have nonprofits, residents, academia. We're targeting a launch in 2022 with the first steps of convening conversations to lay the groundwork for a shared vision. And so if you are interested in your community or institution learning more about participating in the collaborative, please reach out to me. In the follow-up email to this event, we'll include all the resources we've talked about today and all of our contact information.
Thanks, Savannah. I want to quickly turn to Sarah, Groundwork Ohio River Valley's GIS manager. Sarah, at Groundwork, we use data to inform action. Whether it's through Green Youth Workforce or working with partners on policy, we prioritize frontline experiences and solutions. Can you talk about how you view this data action approach as it relates to neighborhood planning?
Yes, thanks, Tanner. And I know there's a lot of questions in the Q&A right now, so I'll try to be brief. Develop's Invest model is an awesome resource that we can use to better understand the environmental needs that are unique to the varying neighborhoods and jurisdictions in Cincinnati and around Cincinnati, which is something that goes hand in hand with the collective awareness of climate justice issues that Groundwork's Climate Safe Neighborhood program hopes to bring. There isn't a lot of regional flood and landslide occurrence data that's easily accessible to the public, making it difficult for residents in neighborhoods to prioritize and understand the scale or patterns of the issues at hand. Research and data related to heat, flood, and landslides allows us to paint a really great picture of the unique climate conditions within each neighborhood, and also work with residents, work with communities to prioritize different adaptation methods. And I wanted to address a great question by Roger in the Q&A addressing, and let me read it. Does the city of Cincinnati have a history of segregation and or redlining? If so, do those maps of historically segregated communities coincide with areas susceptible to low-income flooding and landslides? And while Cincinnati does not have a certified redlining map, I'm sure we've all seen maybe a outline of one. We know that doesn't exclude its neighborhoods from the impacts of federally sanctioned race-based housing segregation. And there is a long documented history of federal and local government sanctioned housing segregation that has modern day impacts on the neighborhood's climate risk. It is in Cincinnati a little bit more difficult than kind of overlaying the redlining map, but using old census tract data dating back to as early as I think 1910, you can definitely see the overlay of current climate issues with race and demographics from the start of the 20th century. Yeah.
Thanks, Sarah. I want to open it up to some of the questions here. I'm guessing that this will be for Celeste or Paxton, but from Devin Shank, he is saying, it is interesting to see wetlands falling in the middle of retention. Can you share more on why you think this is?
Sure. So in the case of the Invest Urban Flood Risk Mitigation Model, a lot of the analysis depended on the soil hydrological raster group and the associated curve numbers. And because wetlands have kind of an intermediate curve number, basically just because of the types of soils that are there, they weren't as effective for the model in retaining that stormwater as the forests were. And that's mostly just because of the water content that's already present in wetlands. So for instance, the capacity per the model of a river would be 0, which is why we chose not to include the river, because of course the Ohio River's capacity for retaining rainfall is not actually 0, but it's just the nature of the model to determine the retention based on soil.
Thank you, Paxton. I'm just going to keep going with questions so we can get as many in as we can before 7. So I believe this will probably be directed towards Savannah. It's from Jim Gleason. He says, landslides are an issue citywide. Is this project just for Cincinnati and Covington? Or is Groundwork and Green Umbrella working with Hamilton County as well? And before I turn it to Savannah, I'll say that because we have the model, we have the ability to set geographies, and we can redo that. Oh, maybe someone can, not I, at any time. Go ahead, Savannah.
Great. Yeah, and some of the tools and resources I mentioned, such as the mitigation tool developed by the Green Space Impact team at Green Umbrella, that is regional, so that it is greater Cincinnati, including Ohio, Kentucky, Indiana geography. And the collaborative similarly will serve greater Cincinnati, so it's not just Cincinnati and Covington. And, I think that could be an opportunity to work towards with other partners to maybe get some of these data in future years.
Thanks, Savannah. Let's stay with you for a second. This is from Sadie. Does Green Umbrella Collaborative offer any opportunity for sister city matchups? To be interested in connecting with a comparable city in the Midwest facing similar challenges?
Oh, that's a great question. I hadn't thought of our collaborative and sister city matchups yet. So this is a new recommendation that we can certainly include. I can recommend some collaboratives that are already in place, since ours is still in development. But in Chicago, I would check out the Greenest Region Compact. That is their collaborative, and it's been in operation for, I think, maybe about 7 years now. And they've activated over 160 jurisdictions, I believe. And so depending on where you are, I think that Greater Chicago has jurisdictions of all sizes. And so you can see a lot of different ways, whether small communities or larger suburbs of Chicago have implemented based off of their collaborative and regional action plan. We hope to create a similar wide range of opportunities for not only cities, but also villages, townships, opportunities for counties, because it really requires a patchwork. These different types of jurisdictions serve different needs. And so we need to make sure we build alignment. And I think that will include having conversations with other cities. One forum I can recommend is through the Georgetown Climate Center. They have a regional collaboratives forum, which is a peer sharing network specifically for collaboratives.
Thanks, Savannah. These are great questions. And I'm going to turn to Michael from Susan here. So she was asking about if OES is also taking the plastic issue into consideration.
So yeah, plastics are obviously a big issue here in the city of Cincinnati. We manage the curbside recycling program to help keep them out of our landfills. We also manage the recycling program at all city facilities. It should be noted that the city of Cincinnati did pass a plastic bag ban. However, unfortunately, the state legislature essentially preempted us. They banned the ban in this year's budget update. So local municipalities in the state of Ohio no longer have the ability to prohibit plastic bags and plastic packaging in their municipal boundaries.
Thanks, Michael. So it's getting hard for me to keep up with all the questions here. And I'm sure some of them were answered in the presentation, and you might have some still remaining, which you will be able to follow up with afterwards, after we send out all the information. We're about to time out, however, and I just want to quickly turn to the presenters for any closing thoughts about what you've heard or discussed or learned today. Michael, please go ahead and start us off with that, please.
Yeah, I just want to thank everyone for the opportunity to talk about what the city is doing here and to gain a little bit more information from NASA and our partners, Tanner and Groundwork Ohio River Valley, for all that you guys are doing. I'm not going to lie, our climate is changing, and we're going to see impacts. We're going to see increased storms. We're going to see hillslides. And we as the city of Cincinnati will need to work to adjust to make our city a more resilient place.
Thanks, Michael. Really appreciate you joining. Savannah, if there's any last words from you, please go ahead.
Yeah, thank you, Tanner. No, I just want to say thanks to everyone on the line, both panelists and attendees. These are the conversations we need to have. This is truly an all hands on deck issue. And so we need folks working at the individual level, at the institutional level, at the government level, and we all need to collaborate. And so I just want to emphasize that point that, it's a daunting task in front of us, but we're not alone. And so definitely lean into all of the resources that we shared today from Groundwork, NASA Develop, the City, and Green Umbrella. We're all working hard to make sure we're in conversation with each other and other partners. We want to bring your voice into this as well. So, You'll receive resources in the follow-up email as well as our contact information, so don't hesitate to reach out.
Thanks, Savannah. Lastly, we'll just say, excuse me, on the Groundwork's end here before the develop team, Sarah.
I just want to thank everyone so much for coming and listening to this. And I want to let everyone know that in terms of the report and getting this information out there, I know that there's a lot of interest in seeing more in-depth findings. The minute this report is approved by NASA and is written, and Celeste and Paxton can speak more to that, it will be released, and we'll also have an accompanying story map. If you're interested in learning a little bit more about what NASA's develop team has done in terms of other research, we have that hosted on our website, groundworkorv.org.
Thanks, Sarah. Paxton, Celeste for the closing words.
Yeah, I'll jump in real quick and just say, mimic everyone else and say thank you to everyone who attended and to the other panelists. This was absolutely incredible. I know there were a couple questions that we didn't get to, so I'll just throw it to that follow-up email, or you can just Google NASA Develop and you can find our email on our page for any other follow-up questions. We'd definitely be happy to talk more about this. And just like Sarah said, we have provided them with all of the data. So any of the maps you saw, if you have follow-up questions or want to look more into those, they have access to that already. And in terms of the technical report, it should be to Sarah and Tanner, I think in a matter of days, if not already. It was just cleared by NASA Export Control. So the technical report is forthcoming. The story map will be following hopefully shortly after. So all of the products will be shared with them, or if you email us at our NASA email, NASA Develop email, which is on our website, we're definitely happy to share them with you as they are released. But thank you again for all the questions and for having us here today.
And thank you all so much for attending. Please keep in touch. We all know how important these issues are, and we're all working really hard together. So thank you again, and we'll see you next time.